Welcome to our video on recursive formulas. This is by 3mathguys. Visit us at 3mathguys.com and please subscribe. Okay, so if we're looking at sequences and we want to write something called a recursive formula, how do we go about doing that? That's what today's video is going to be about. So let's take an example sequence. And if you take a look here, you can probably start to see the pattern here. I'm just going, plus 5, plus 5, plus 5 over and over. Okay? And so just kind of a quick recap here. You could think of a sequence, a lot of times we think about it in terms of a table, an input-output table. And so this would be the first number in my sequence. We call that the first term, second term, third term, and so on. Well, there's two kinds of rules or formulas that we're usually trying to find, and so the first one, which you can go watch our videos about, is how do we turn this 1 into a -8, and I'm looking for a rule that does that, and where the same exact rule will also turn this 2 into a -3 and this 3 into a 2, and so basically a rule that is turning these input values into the output values, and that kind of rule is something we call an explicit rule. Okay, now today we're going to look at a recursive rule, which is actually slightly different. It's a rule that will turn this number into this number, this output value into the next output value, and into the next output value. So hopefully that clarifies the distinction between the two. Explicit rules will turn this one into this one. Recursive rules turn this one into this one. Okay? So just to kind of, how do we think about that? That's great. We know the pattern on this example, but how do we make a rule that's more abstract, that's more general, that can describe this? Okay? So one way to think about it is something like this. Like if this was my sequence, and it kept on going, and it had numbers before it, but I just picked any spot somewhere along the way. Let's just call this any number, right? So I have any number in my sequence. Well, how do I find that any number? I'm going plus 5, right, to turn this into that. Well, what would I call this, this one here? Well, I'm just going to call this the number before. Right, so if I take the number before and I add 5, I get any number I want. Like, I don't know if that makes sense. If you need to pause it or think about that, but I could write a rule that said any number is equal to the number before plus 5. And that would be my equation. So any number is equal to the number before it plus 5. And that makes sense. It's just describing what's happening. How do I get to 7? Well, I take the number before it and I add 5, and it gives me that number I wanted. Okay, but in math, we're not going to use words like this. We're going to try to be a little more efficient. And so we're going to use function notation to really say the same thing as this. And so instead of saying any number, I could just say, well, what term do I want to talk about? Well, any one I want. Let's just say this is n, the nth term. Well, then this any number in the sequence I want would be called f of n. And if this is f of n, well, then what do we call these other things around it? If this was n, wouldn't this be 1 more than n? I could say, well, this is n plus 1, and this is 1 less than n, so I could say this is n minus 1. Well, what does that make these? That makes this the f of the input, which is n minus 1, and this would be f of n plus 1. And if you need to pause the video and really try to make sense of that in your head, go ahead and do that, because if this makes sense to you, then these recursive rules will be very easy. But if you just kind of gloss over this part, they can be confusing until you really have a solid understanding of this. So if I call any number n, the one before it is n minus 1. If I'm talking about the output values, that's f of n minus 1. Okay, so let's basically write this same rule we just did, but using our function notation. So any number, in this case I'll call that f of n, is going to be equal to the number that came before, which in this case we will call that f of n minus 1. And on the sequence I started with, as an example, I'm adding 5. So I'm going to say plus 5. And then one other part we add to recursive rules is we like to say, well, where did this thing start at? I'm just describing the pattern, but this sequence had a beginning. Where was it? Well, the example I gave, the beginning term, this first term was a negative 8. So in addition to this pattern, I'm going to say also the f of 1 was negative 8. And this is typically how we will write a recursive rule for this sequence. And if the pattern changed, if this was adding by 10, well, then I'd put plus 10. And if this started at 13, then I would change this to where it started. But this is the pattern you're going to see. Okay? But that's not the only way I could write a rule. I could write other things that still make sense. I could say something like this. F of n plus 1 equals, and you want to stop and think, what does that mean? F of n plus 1. Well, how would I get this? How would I get this number? Well, wouldn't I take this and add 5 to it? Right? So I could say, if I started my rule with this, f of n plus 1, I would say I'm going to take f of n, which came before it, and I'm going to add 5. And the same thing, f of 1 is minus 8. So if you see it that way, it's really saying the same thing. More often you'll see it this way. Okay? So let's take a look at a couple other examples. Now, I could, let's say I gave you a rule. Let's see if we can find the sequence that works for that rule. So just as an example, let's say I had something like this. I've got this recursive rule, f of n equals f of n minus 1 minus 2, and let's say f of 1 was 10. Well, can I write a sequence to match this? And first, how do I tell that this is a recursive rule? One way to tell is f of n and f of n minus 1. These are both going to be output values, and that's kind of a giveaway. And typically explicit rules don't have the f of 1 value. So, well, what is this saying? What's my first term in the sequence? A 10. What's the next term going to be? Well, to find any term I want, I take the term before it minus 2. So I'm going to go minus 2, and I'll be at 8, 6, 4, and so on. And I have my sequence based on that rule. Okay? Well, let's take a look at another example. What if I had a sequence, let's say 400, and then the next term is going to be 100, 25, let's say 25 over 4, and in this sequence you might notice, oh, well, you're dividing by 4. But remember, in sequences we want to describe it in terms of multiplication. And so what am I doing to turn this 400 into a 100? Well, I'm going times 1/4, times 1/4, times 1/4. So if I want to write a rule, a recursive rule that describes this, I could say, well, any term in my sequence can be found. Let's say, for example, I call this my f of n, well, then this would be the f of n minus 1. So any term could be found by taking the term before it times 1/4, right? Times 1/4. But more often you'll see times 1/4, instead of writing it on the end here, you can put it right here in front. So any term in my sequence is going to be found by taking 1/4 times the number that came before it. And we still want to say, where did this thing start at? So I could say, well, this thing started my f of 1 value was 400. And so this is going to be a recursive rule for a geometric sequence, one that's multiplying over and over. Okay, so let's look at one last example. And this is one of my favorite patterns. It's one you might have seen before. If you're not familiar with it, this is a famous pattern in math, but take a look. Can you figure out what's coming next? And you might want to pause the video if you've never seen this sequence before. And we're going to end up with a 13. And if you notice the pattern, the way this thing moves, it's not adding by the same amount, but if I take 1 plus 1, I get 2. If I take 1 plus 2, I get 3. 3 plus 5 is 8, and so on. So if I add up the two numbers, it tells me the next term in the sequence. Okay? So how do I write that recursively? Well, let's kind of think about this. So all right, any number in my sequence, how would I find that? If I describe this 5 as f of n, then what would I call this 3? Well, this would be f of n minus 1, right? And this 2 would be f of n minus 2, and minus 3, and 4, and so on, or f of n plus 1 plus 2, right? So any f of n that I want to find can be found by adding these two up. So that's what I'm going to write. I can take f of n minus 2 plus f of n minus 1, and that's going to be the pattern. Any number will equal the one that is 2 behind it in the sequence plus the one that is 1 behind it in the sequence, and those added up give me any term I want in the sequence. And we do want to say where this thing started, so I could say, well, the first term in this sequence was a 1, and since it takes 2 terms to find the third term, I'm also going to say that f of 2 was also a 1, so I can start by adding these two and then continue using this pattern. Okay, so hopefully that gives you an overview of recursive formulas, and really I'll just go back to this quickly. The key is understanding this part right here, describing a sequence in function notation. If that makes sense, then you shouldn't have any trouble. Alright, this has been 3 Math Guys, and hopefully you'll watch some more videos. Thanks.